Today I'm going to be making some nice and scary bromine. Bromine's a very dark red, almost black liquid, which emits a bunch of reddish-orange gas. It's one of the only two elements which is a liquid at room temperature. I'm going to make it both because it's fun, toxic, and because it's also quite beautiful. To begin, I start by adding 50 grams of calcium hypochlorite into a large 3-necked flask. Calcium hypochlorite can easily be found as pool chlorine. On top of the hypochlorite, I add 90 grams of sodium bromide. I then add 200 milliliters of distilled water. I then turn on the magnetic stirring and begin mixing everything. I then set up an addition funnel on the left, a stopper on the right, and a 3-way adapter in the middle. I then complete the distillation setup with a condenser and a receiving flask. To begin, I add 100 milliliters of concentrated hydrochloric acid into the addition funnel. I then slowly open the valve and drip in the hydrochloric acid into the mixture. As you can see, as soon as the hydrochloric acid drips in, a strong orange color is formed. The orange color is bromine. Here's what's going on. First, the hydrochloric acid reacts with the calcium hypochlorite to form chlorine gas. The chlorine gas then reacts with the sodium bromide to form bromine and sodium chloride. The reaction is not super efficient because some of the chlorine gas escapes and does not react with the sodium bromide. As you can see, as we add more hydrochloric acid, the concentration of bromine vapors increases. Bromine boils at around 59 degrees Celsius, and the heat of the reaction exceeds that, so as the bromine is formed, it evaporates and creates this really nice red gas. Soon the whole setup is filled with bromine vapors. You may notice that the bromine is not condensing yet. This is actually because most of the gas that's in the setup is actually chlorine gas, which escaped before reacting with the sodium bromide. It has this dark red color because it carried along some of the bromine with it, but all the chlorine is preventing the bromine from being condensed. However, this problem is going to be fixed by itself as we generate more bromine. Eventually though, some of the bromine starts condensing, and you can see this as some little red droplets in the condenser. It looks almost like blood. Once all the hydrochloric acid had been added, I sealed the valve. Eventually the rate of bromine production speeds up and we start seeing a bunch of drops in the condenser. Soon after, we start seeing drops of bromine collecting in the flask. As you can see, the whole setup is filled with dark red bromine fumes. Once bromine stops coming over, I turn off the heating mantle, and as you can see in the collection flask, we're left with two separate layers. The upper layer is mostly water, with a small amount of bromine dissolved into it, and the darker lower layer is all of our bromine. I then detach the collection flask, and using a Pasteur pipette, I pipette all of the lower bromine layer into a vial. As you can see, we're left with a bunch of scary-looking bromine. To store bromine safely, I place it in a couple glass ampules and seal them using a blowtorch. Bromine is very difficult to store since it tends to leak out of every little hole, so the only way to properly store it is using glass ampules. The final yield of bromine was 11.4 milliliters, or 35.7 grams, which corresponds to a 63.5% yield. It's a pretty decent yield considering the reaction is not super efficient, so I'm quite happy. I also had a third ampule of bromine which I made in a previous run. I didn't have a test tube that was large enough to store all the bromine and make an ampule out of it, so I had to store it in 3 separate ampules. It's important to note that bromine is a very dangerous element. It's both corrosive and toxic, and it can easily end you if you breathe in too much of it. It's still manageable with enough safety equipment, but I still don't recommend making it because it's quite dangerous. On a side note, I also kept the upper layer of bromine water. Bromine water is quite useful and is used in the detection of carbon-carbon double bonds. The test works because bromine water is orange. If you drip bromine water onto a compound that contains alkene groups, the bromine reacts with the double bond and turns it into a dibromoalkane, which is colorless, and therefore the orange color is going to disappear. Anyways, I had quite fun working with bromine, and I'll see you in the next video.